All right, so I just got my final boards in the mail and wanted to just go over how they work and give some understanding of the designs and stuff to let you guys know what I'm working on. So this is one board I just posted to my social media and I actually got it back. I have not tested this yet, but this is a board that I'm not sure if I'll use in the end or if this will be like a homebrew thing or not. But basically there's a USB port here, comes into a microcontroller that's got 100 pins. 80 of those can be inputs and outputs. So this is like an all-in-one system here where these plugs here where you could plug in, let me see here. So like you'd have a normal plug. Those would be in there as pins where you could plug something in. I'll show you the picture of that. But you can basically connect both of these ends to a switch, and if the switch is on, it'll send a signal from this line across the switch back to the other line, and it'll go right back in as an input, and it can read that as a switch. So you have all these direct input switches. You can also just take the first one, if you configure it as an output, you can take that first pin there, forget about the second one, and just jump this over and be an output. So this can jump over, you can put a jumper and have it go to here, and this can trigger a coil through here. So these are all MOSFET coils right here. So you can just jump over and make a bridge connection. So you can kind of pick and choose in software on the Windows PC that I have, and you can say I want pin 1 through 5 to be MOSFET triggers and trigger coils. So you can jump the first 5 pins, then the next ones can be whatever and go to be outputs or do whatever you want to do with switches and different things. So I also have embedded right here, these are 10 opto boards, so you can plug in an opto right here with the plus and minus. Plus and minus, plus and minus, plus and minus, up to 10 of them. So you plug in an opto, what it'll do, these are on by default. You plug in an opto there, if it sends a signal that it's getting an infrared signal from a beam, it'll power this up, and then it'll go to this pin right here. And if you want to use that pin as an input, you would just literally connect a jumper wire. Let me see if I have a jumper here. So right, you could just put a jumper wire here from this pin, and then plug the other end right into there, and then that pin would connect right into here. So if you have it plugged in there, it would read the opto if it's being blocked or not. Again, another direct input, and you can choose up to 10 optos. If you need more, you can expand it, but it's an all-in-one board right here. And then of course, just give you an idea, right? So we have little MOSFET transistors that power on coils and turn on high voltages. So these would just go across the bridge here. So these would normally come out of the factory already on, and if they break, much like other companies do, you can solder some in yourself. I might just ship it that way anyway, just so you can choose how many you want to have installed. We'll see, but it's pretty cheap. So this board is really cheap to manufacture, and I can offer it really cheap to people. So again, that's kind of the footprint there if you were to just slap it on your board. We'll test it out and see if it works at some point, but that's not my go-to board right now. So my go-to setup is this. You have a little board like this. This doesn't have all the components on it. So this is the brains board for my entire system. You have a little processor here. It's got 48 megahertz. And then it has some inputs and outputs that it can read through different systems. So these go to other boards, and then they come in and it reads it. So you have this board. If you want to have inputs, you plug it in and connect to this. So this is 8 inputs, any switch, opto, whatever, any kind of switch goes here. And then you can have multiples of these, right? So you can just connect these in series with each other, right? So you would just connect them to this, and then this one connects to there, and they all connect right back to here. So you can just configure how many boards and how many switches you want, and then this can go ahead and test every single thing. So it basically goes, if you're not familiar, it goes one by one. It'll put a high voltage on just this pin, and it'll go from here, and if it makes a connection through the physical switch, it'll end up there. And then it'll put a high voltage on the next pin, but all the other ones will be 0, and it'll go through there, and it'll wrap around. If the switch makes a connection physically, it'll come back onto this back pin. So all these pins will turn on with a high voltage, or not high voltage, but a voltage, one by one by one by one by one by one, and then it knows that if that connects while that pin is on, and this pin comes back to the CPU, that it read a high voltage, and it knows that pin 1 or pin 2 or pin 3 has a voltage. So these are shift registers, right? So you get eight per chip, and you can just, again, chain these as many as you want. So as many as you need to complete the system, you just keep putting them together, and then the last pin right here goes right into the controller board, and it knows what pin it turned on and if it's reading a switch or not. So that's kind of the main setup of that system. Then the other thing would be, so those are the inputs, and you need outputs to trigger coils. So this was one of my older boards, just so you can see though. All the MOSFETs are right here. Again, you get 8, so we put them, all these can go in series. You can have one here, you can have another one over here, and another one, just depending on how many you want, where you want to scatter them. You want to be close to coils so that you can plug them in with different coils. So the front board, the front of the board, the coils, you can plug them all in there, and then maybe have one in the back where all those coils can plug in one junction, rather than wire them all back to one physical board. So again, with where did I put it? Oh, it's right here. Again, so like with this board design, every single input and output has to come from here. So all of these would have to route to every single coil in the system, all the flippers and everything. And those would have to go all the way up and down the playfield and come back. Same thing with every switch. If there's a switch in the back, it would have to go all the way to the back and then trace back all the way to here. So everything is built into this system. Whereas this is more node-based, what I'm talking about, where you just have a tiny little board and it's talking to all these other little components. These are dummy systems. All they do is output on different pins. They don't talk back and forth here. They just output a voltage on any of these. They're not smart or intelligent, really. So again, you can input and output with this to different boards. Here's a newer version of this one. So I've been slimming these down more and more over time, just different designs. So what you'll see here is these are, you could use a logic level MOSFET, but if you're familiar with that, I actually boost the signal up to 12 volts so that every single MOSFET is getting a full boost of high voltage to drive the other high voltage line, right? So you're taking 12 volts and you're powering the 48 volt line. So again, well, let's continue with this. So these are the backlight LEDs. I actually noticed the other day there was another company, I won't say, but they have a very similar design where theirs are a little bit longer, but you can just drill these up and put them in the back box to illuminate them, and you can dim them as well. Here's a little opto conditioning board. Normally, if you look at other brands, they'll have the actual opto LED for the IR beam built right in here, and they'll be put above the playfield. So if the ball crosses it, it'll block the beam coming across from it. I decided to put these boards underneath the playfield so that they're kind of hidden and they get protected from damage. So you plug in an opto here and just trace the wires up, and only the actual LED, right, like a little one of these things, right, just the LED is going to be on top to detect the ball. There was somebody that was saying an issue that in one of the games it was hitting and it was knocking this little tiny chip here. I don't know if you can really see the focus on it, but yeah, it was knocking this chip off, and it would ruin the opto beam. It wouldn't work anymore. So just protecting it from that kind of damage. It's also really cheap, right? Because you can just plug these in and then reroute the opto wherever you want. There's custom boards for other games. I know there's one game that has like 3 optos in one, and that board's like $70 to replace, and then it goes out of stock and there's nothing you can do. So this is very modular. You just plug it in, put your optos wherever you want in 3D position, and there's your beam, and you can detect if it gets cut off or not, if a ball's traveling through that infrared beam. Final thing is, I haven't tested these out, but I decided to go like everybody else, just with RGB insert LEDs. So usually when you have an arrow that says shoot here or here, right, nowadays they're all different colors. They can be any color you want at any time programmatically. My original plan was really just to have one color or so, just to keep it you know, visually like dark and gloomy, not just be like all rainbow of colors, but you know, we can still program it any way we want, and I think that's what you need for people coming into the hobby if we're going to support actually hobbyists. If we go back in history, Here's one of the boards I did. I don't know if this came first or my other one, but this was my original board. So it's the same processor here, 48 megahertz. These were all of the inputs here, so 32 inputs. And you would just connect them here. And then these were all outputs just to do whatever. They could output to a light, they could output to a coil, they could output to a motor. And that was the original board, was just this really long, thin board that would just, again, get mounted somewhere in the system. Kind of like if here's the play field, it would just get mounted vertically like that, and you just plug things in. But again, they all trace back to one spot, which is, it gets a little bit hard to debug and find different issues when all the wires go to one spot. And then also I had this really long MOSFET board to kind of go along with that. So you would plug in, all those outputs could go to any of these inputs and trigger a coil through here. So I then came up with another design. I don't know which one of these came first, but I can tell you about them. They're both very similar, right? So if we talk about this one, same design. This was going to have two 48 megahertz controllers that can talk to each other and do different things. But essentially it's the same kind of thing. These are all outputs across the bottom here. This chip would actually drive directly to transistors that would trigger coils, and then these outputs could go and do whatever they wanted. They could also be switches as well, so you could output something and then read it on here, I believe. My other board, I'm pretty sure this one came next. Same thing, you have a 48 megahertz controller here. These chips control the inputs, so there were 32 inputs, there's 8 per chip. And you would just plug in your switches here, and if they made a physical contact, it would signal it back into here. Same way that I just talked about on the other, the current system, same kind of chip, it's just a little different size. And then these were outputs as well, so we just shift all these different outputs to do different things. And likewise here, the first chip here was dedicated to these transistors for the optos. So you had optos where you could plug the switch directly in here, and then the system knew that it was directly an opto and that it had to come through here and read it a little bit differently. And then also there was some transistors here that automatically supported my shaker motors by the flippers. So those were kind of the designs that I had and where they've come from. And just a couple other boards. So I originally was making my own segmented display. Remember, I was not going to do a LCD with like video game animations and videos and stuff. I was just going to do a scoreboard, which was like really big like this. Here was kind of how that was going to look. It's not complete here with the display, but there was just going to be, you know, segmented displays, and it would just go right up onto the back box. So that was a board design there. And then after that, I was going to do, before I went to an LCD, I was going to do a dual layer one. So you had a top and bottom. So you had 8 or 9 across the top and then across the bottom as well. So you could just display more information, basically. And then I scrapped that and went to a full-on LCD so I could program everything in Windows and it would work on my video game software. Yeah, that's pretty much it. So again, you just have this small chip here, right? Powers and different things come in here, and then it just has a couple data lines to go out to other chips and these node chips that bring signals back in, or it just pushes signals across that this chip talks to the next chip, talks to the next chip. And yeah, it's a little bit more easier. It's easier to debug, I feel that way. And with these other chips not actually being smart chips like some other brands, right? They'll have a node system where a chip talks to another chip, they talk back and forth, and one can control 8 coils, and this one can control 8 coils, and that one can control 8 coils. This is the only brains. So when you're debugging, you can kind of just look here and see, like, you know, is this chip working or not? You know, you can throw it out and get a new one for really cheap, but you can kind of detect voltages very easily, see if something's wrong. If you're going to go and play with, if you want to test a coil, you can literally just, you know, take one of the input pins and ground it and see if it will trigger the coil or not. You can test if it's got 12 volts. You can test if the coil has 48 volts. You can test all these things very easily. So that's kind of the system I got, and you you know, after building this up over time, seeing what I like and what I don't like, and this is kind of what I've come to. It's also a very cheap and inexpensive platform to be on, and yeah, that's it.